Okay, so now let's look at how to build an exponential model when we know the initial value and the percent change. So if a set of data has initial value a and the constant percent change r written in decimals and the input x are equally spaced, then the data can be modeled by exponential functions. So when the quantity increases over time, we can use the model y equals a times 1 plus r to the power x. But when the quantity decreases, we can use y equals a times 1 minus r to the power x. So remember, over here a represents the starting amount and r represents the rate of change as a decimal, and also here x represents the number of time intervals. So let's try some examples. Okay, so let's look at a real world example, which is about inflation. So suppose inflation averages 4% per year from 2000 to 2010. So that means if an item cost $1 in 2000, it will cost $1.04 in the next year, which means in 2001. So in 2002, it will cost around 1.04 multiplied by 1.04. So this is the key. So in the second year, we are not adding 4 cents again. So instead, we are multiplying the new amount by 1.04. So if you are looking at 2003, the new cost will be around 1.04 multiplied by 1.04 multiplied by 1.04. So likewise, if you're asked to write an expression that give you the cost in t years after 2000 for an item cost around $1, so you can write the formula as 1 multiplied by, that is the initial amount. So you have to multiply this factor t times. So I'm going to represent that by exponent t. So this is a cost function, so I'm going to represent it by t, and it's a function of t, so I'm going to write it like this. So this expression will give you the cost t years after 2000 of an item cost of around $1. Okay, moving on, the second part. So here you have to write an expression for cost t, for the cost of t years after 2000. But here in this time, the initial amount of the cost is $100. So in this problem, in part A, actually we started with $1, but here we initial cost is $100. So that means you have to just replace initial value by 100. So you can write the formula as the cost function as 100 multiplied by 1.04 to the power t. So this model can cost, that means this models the cost of an item t years after 2000, starting at $100 in 2000. Okay, part C. So you have to use this model to find the cost of an item from part B in 2010. Okay, so 2010 is 10 years after 2000. So in this time, t is equals to 10. So let's plug this t value into our function. So initially my function is this. This is the function. So now I have to substitute t equals 100. So that will give me, t equals 10. 0.4 to the power 10. So if you use your calculator to evaluate this value, you will get around $148.02. Okay, so due to inflation, something that cost $100 in 2000 would cost about 148.02 in 2010. So basically, the inflation increases the value by a percent each year, and that's exactly what exponential growth models.